Hello, and thank you for joining us. Today, we would like to share with you a solution developed for our port customers. Now, a port by nature is a complex intermodal and multimodal facility, and as a result, ports are tasked with managing the movement of millions of containers annually using multiple modes of transportation and hosting a diverse set of vendors. And believe it or not, it's not uncommon for a port to have little to no visibility into vendor activity or train movement, especially when they're dealing with the Class 1 railroads. That's something that really caught me by surprise. You see, in most cases, the railroads view their movements and carload content to be proprietary and will only share portions of the data with the ports. And that often leaves the ports at a serious disadvantage in that they have to rely on the railroads to supply the data that they need to establish metrics, apply for funding, or plan rail expansions within the port. So, in partnership with our port customers, we developed a solution to address this issue. We call it train counting and identification with AI ML. The train counting and identification app, it helps our customers to take advantage of three key benefits: improved safety and security, increased visibility to rail traffic data, and improved maintenance planning. Now, these benefits are only achievable with the correct quality and quantity of data needed to produce the outcomes your organization desires. And since we know that most ports do not currently possess the data needed, Jim's going to share with you a demo that shows how machine learning technology can be used to provide this much needed capability to capture that data. Then once we have that data, we can then leverage it to achieve these three benefits.
Thanks, Mark. This is the demo for the solution for counting and categorizing train cars from video using deep learning. Video of trains passing by can be used to build a deep learning model that recognizes trains, can count its cars, and can categorize those cars by type. For example, it can recognize whether a train car is a locomotive, a boxcar, a tank, hopper, flat car with containers, and so on. So that given new video, the number of train cars and their types can be captured, can be displayed on a map and a dashboard, and can be stored in a database for analysis and reporting over time. This solution uses the ArcGIS.Learn module of the ArcGIS API for Python, as well as ArcGIS dashboards. In this demo, I'm playing the role of a rail yard operations manager at a maritime port. Let's see how this works. Here on the left, we see a list of trains that have either arrived at or departed from the port's rail yard. In the list, some of the more important information is shown, like train number, the count of rail cars attached to that train, and whether it's arriving or departing. When I click on one of them, Camera 5 flashes on the map, a pop-up opens showing more detailed information about that train, and also a video that you can play that shows the actual train, along with the visuals that describe the feature extraction performed by the deep learning model. It's counting the rail cars, and it's also identifying them by type. If I click on one of the cameras on the map, the pop-up shows me all of the trains that passed camera 3 arriving or departing from the port on that track that day. Okay, so let's go under the hood a bit and see how this works. The first step in training a deep learning model is to label all of the features that you want the model to detect. There are many ways to do this, but this software here, called Label Image, is very handy. For each image, you draw a box around the object. Here we're training the model to recognize what a locomotive looks like. Here we're training the model to learn what a boxcar looks like, or a hopper, or a flat car with containers, and so on. For each image, an XML file is created with all of the labeling information entered in a format that the deep learning processing is expecting. And here on the right is a Python script that we use to train the deep learning model. For this purpose, we're using the ArcGIS.Learn module from the ArcGIS API for Python. This module wraps up many libraries that can do artificial intelligence, machine learning, and deep learning, making it all easier to use from one single Python module. Under the hood, this particular operation uses TensorFlow, FastAI, PyTorch, and a few others. But that's all abstracted away from you, making it easier to use. Generally speaking, the more training data you have, the better and more accurately the model will perform. For example, this particular model, we labeled over 3,000 features on about 1,000 different images. Once the deep learning model is trained, now we have it process new video that it's never seen before. For each frame of that video, the routines will scan the image, looking for patterns that match what it had previously learned. The EMD file points to the model that you had previously built, that you want to use. The MP4 file is the new video that you want the model to do the feature detection on. And the CSV file contains the results that we can then convert into a hosted feature layer. And it looks like any other layer, as we can see here on the map. It contains information about the train car counts, the category types, as well as a date timestamp for when that train passed through. And what you see here is the result of the feature detection process performed by the deep learning capabilities of the ArcGIS API for Python, displayed in a simple, handy dashboard. Back to you, Mark.
Thanks, Jim. Now, if you remember the first benefit I mentioned, improved safety and security, this is achieved through increased operational awareness, allowing the security team to have near real-time notification of when trains arrive and depart, and then communicate train movement to the rest of the organization. With so many different operations happening within the port, it's important to be able to communicate the movement of such large assets, because we already know communication across organizations saves lives. The second benefit is increased visibility to rail traffic data. In this new world of IoT and digital journeys, we know that data is king. So this solution gives the power back to our port customers, giving them the ability to collect, store, analyze, and even visualize their rail metric data. That data that's needed for marketing, funding, project planning, and just overall greater understanding of the operations within the port. And because they collected the data, they can be confident in the source. Finally, improved maintenance planning. Because this solution allows customers to collect data related to train movement, they're able to gain insight into just how much use the track and ties are getting, which gives customers the ability to make more informed decisions when building maintenance plans based on more accurate current condition and life cycle expectations. So just to recap, there are 3 key benefits to implementing this solution: improved safety and security, increased visibility to rail traffic data, and improved maintenance planning. If you have any questions, or if you're wondering how this technology might fit or benefit your organization, please reach out. Knowing that each organization is different, we usually follow a plan that looks like this: setting up a discovery workshop so that we can identify your specific needs and understand your data and system infrastructure. If it's a good fit, and we agree that we can help you to achieve your organization's desired outcomes, we'll move to the proposal phase and, of course, ultimately the implementation phase. I want to thank you for taking the time to watch this video, and we look forward to hearing from you soon.